G'day Year 10, just running through a question from exercise 4F, question 7 here. An aeroplane is flying due north, so in that direction there, north, but to avoid a storm it flies 150 kilometres on a bearing of 60 degrees true, so that angle in there is going to be 60 degrees from the northerly direction. There's 150 kilometres already provided there for us, and then on a bearing of 320, so it's going to be 320 all the way back around to there, which of course is probably easy to think of as this angle in here being 40 degrees, because 360 minus 320, that gives me that angle in there being 40 degrees. We're going to come back to that in a minute. I might actually just write that where it won't be in the way. Until it reaches its original course, and then it can continue flying north again. Find the angles ABC, so that's this angle in here, ABC, and then find angle ACB. So we need to find the two other angles inside our triangle. We know one of them's already 60. So how can we go about doing this? There's a couple of ways. We could use the fact that these northerly lines, when you're dealing with north, we can treat those as parallel lines. So if this is 60 degrees here, then the other angle AB and up to north would be co-interior with it. We could use our parallel line rules, which would make that entire angle 120, or this angle in here 80. That's one way you could do it. Another way you could do it there is if that 60 degree bearing, if I just continued that line on, we're using corresponding angles, this would still be a bearing of 60 degrees, wouldn't it? So if I've got 60 degrees, it doesn't look like 60, that looks slightly more 60-like. 6 degrees there and 40 degrees there. Obviously, all three of those angles have to add up to 180, so I still get 80 in there. So angle ABC is going to be 80 degrees. From there, well, 80 and 60, that's going to give me 140, which leaves me with 40 degrees there for angle C. That's our first step, part A done. So, how much farther did the aeroplane have to fly? So, it was going to fly just A to C, and instead it flew 150 kilometres A to B, and then some other distance from B to C. So we can find the extra distance would obviously be, let me write that out first. Extra distance is going to be AB plus BC minus what they were originally going to fly, which was AC. And all I know at the moment is that AB is 150. So we need to come back up here to our triangle and see if we can find both length BC from B to C and also AC. And when you've got an opposite angle side pair and we're looking for other sides, I think the sine rule is going to be useful here. So if I'm looking for BC first of all, BC divided by the sine of 60 would be exactly the same as 150 kilometres divided by the sine of its opposite angle, which is 40. And BC is therefore going to be 150 divided by sine 40 multiplied by sine 60. And pushing buttons on your calculator will give you an approximate answer there. Similarly, I can do the same for length AC. AC divided by sine 80. My stylus battery, or I think it's actually just the computers are getting old. They're starting to play up a little bit, so apologies again for that. And I'm going to stick with the original one that I had, so 150 divided by sine 40. But it wouldn't matter if I used whatever length BC that you find here divided by sine 60. It'll give me the same answer. AC is approximately equal to 150 sine 80 divided by sine 40. Actually, it's still equal to that. And then it's going to be approximately equal to, once we actually go ahead and push buttons on our calculator. The little line above those letters just indicates the distance from A to C, or the length of the line segment AC. I I don't have a calculator on me. Hopefully you can push your buttons on the calculator, make sure you're in degrees mode, substitute those values in for BC and AC, and you will get a number for the extra distance. I hope that helps. All right, catch you in the next video. Bye.